This video demonstrates the lean concepts of takt time and line balancing. Here we're going to be making a sign that says takt, T-A-K-T, exclamation mark. And we have a customer demand for this sign that's 1.25 signs per second. The time to produce each letter is a T takes 1 second, an A takes 1, a K takes 1.5, another T takes 1, and the exclamation mark takes a half a second because it's the simplest. Assembling the completed letters into the sign takes 1 second, and we have 4 letter making machines that each produce letters. Because this is a long production run, we can ignore the first few seconds while the system warms up. The time will be negligible. Let's also assume that there's no setup time or changeover time. So if a machine goes from letter, say, producing A's to K's, there's no time to set that up. It will happen immediately. We'll also assume that there's no randomness and that our system is in continuous operation. Times are known to make the letters and that they're stable. Your instructor can talk more about how these assumptions could impact a real-life system. So let's go ahead and take a look at the model. And what we have here, recall takt time is 1.25 seconds. And what we have here is my controls that I'm going to use to run it. We're going to run it for 65 seconds. And let's go ahead and start. So I'm paused it already. And we can see is this one's really making a lot of exclamation marks because they only take half a second each. But we only got 1 K. We also have a T and an A, and another one should be coming out soon. Okay, so what happens here is we got the T's went into the first bin, A went into the second, K went into the third. It needed another T for the fourth bin, and the fifth bin was the exclamation mark, and then it assembles it and goes off the line. So here you can see we have another one ready. It's waiting for this T to come into this bin, at which time it will start to assemble it. And that's what happened. It goes so fast you don't see it stay there. So let's go ahead and run it for the whole 65 seconds. And what we'll see when we do that we've produced an incredible number of exclamation marks, a lot of A's and K's as well, but we're short of the T's. So the T is our bottleneck. It takes 2 seconds between each sign, and that's because each T takes 1 second and we have 2 of them. So I think it's pretty obvious this is not a very good system. So let's go ahead and clear out the data. And let's go ahead and think about how we can improve this. So what I'm going to ask you to do is to get out some paper and a pen and make a little grid for yourself like this. It doesn't have to be fancy. And map out how you could produce the letters better on each machine. Recall that we could put, for example, a K and then an A if we wanted to. We don't have to do only K's or only A's. So say, for example, you wanted the first machine to make T's. Draw a box around the first 2 blocks because it takes 1 second, and each block is a half a second. And then put a T in the middle. And then you could graph it out that way, what each machine will make. So take a few minutes and do that. And when you're ready to restart the video, just hit play. Okay, at this point I'm assuming that you've already graphed out your solution and that you're ready to see the solution that we came up with. So here's our solution. And this is an optimal solution, but it's not the only solution. So yours could give the same result but look different. In ours, we got machine 1 going a K and then an A. Machine 2 is a T, exclamation T. Machine 3 is an A and a K. And machine 4 is a T, and exclamation mark. So you see the yellow ones will give us what we need to make the first sign, and the green will give us what we need to make the second sign. So we'd expect that the first one will take 1.5 seconds, and then 1 second after that, the second sign will be produced. So the first time between signs will be 1 second. Then it's going to take another 1.5 seconds to make the next sign, and then a second, then 1.5 seconds. So you can see that cycle repeat, and we should converge on 1.25 seconds. Let's see if that's really what happens. Okay, I'm going to make it so you can see my controls. Recall takt time is 1.25 seconds per part. Okay, so now you see we're producing the sequences as shown. They're coming off in that order. And now we've got two T's, and we're just waiting for the exclamation mark and a K, which are ready to come. So we're producing signs much quicker. And we'll go ahead and run this for the whole 65 seconds. I'll speed it up. And notice the time achieved is starting to settle on 1.25. So with that, I think we saw a big advantage to being able to do some balancing here between the machines. And also, we definitely benefited from the fact that we assumed no setup time. If we had setup time, this answer would not work. Also, if we had variation, it would cause problems as well.